Hello and welcome to this comprehensive guide for engine heads. This is part 1 of the series, and in this video we'll look into the different combustion chamber designs. The job of the combustion chamber is to position the valves to let air in and out, redirect all the air into the spark plug, and create an even fast propagating flame front. Now let's see how each design accomplishes this. We will judge each head for its ability to flow, squish, and burn the air fuel mixture. The flathead is the first head design predating all the others. As you can see, in the flathead, the valves are moved into the block itself, while the head only contains the spark plug. In retrospect, moving the valves to the block is a horrible idea. The air has to make a full 180-degree turn just to get in and out. It can have only 2 tiny valves, and it struggles to achieve any meaningful compression. There is no squish, and the flame front is way too wide. After the invention of the overhead valve design, also known as push rods, the valves were moved into the head, so this leads us to the tub design. The design is called a tub as it looks like a bathtub. It has the valves straight vertically. As you can see, we can only fit 2 valves, limiting the airflow. The valves being straight means the ports have an unideal angle. It is a big improvement over the flathead. As you can see, also we have this material that gives it its tub shape. Their purpose is to create a volume for the air and fuel mixture to get compressed into and squished into. They are also known as squish zones. They direct the air and fuel into the space. Since the valves are in the way, the spark plug is on the side. This will create an uneven burn, leading to a higher chance of detonation, also known as knocking. The large volume also creates a slower burning flame. The ports are right next to each other, which means the heat from the exhaust is radiating, heating up the intake, reducing density and power. Even with its many drawbacks, it is still the most common out there. So to recap to this point, detonation is also known as knock. The flathead sucks, it cannot achieve good compression or flow. Bathtub design is better, but it still kind of sucks. The next combustion chamber on our list is the wedge design. It isn't hard to see why it's called that. The wedge is a pretty big improvement over the tub. We still have a limit of 2 valves, but with the smaller volume, we can achieve much higher compression, increasing efficiency and power. The spark plug could be on the top, or the side. The squish areas direct the mixture into a tiny space, achieving a more homogeneous mixture. The combination of all of the factors leads to a fast burning, great propagating flame front, creating a pretty good knock resistance. The wedge shape creates a valve included angle, leading to a much better port shape. The heat radiating from the exhaust could assist the carbureted engines by keeping the fuel mixture vaporized for a longer amount of time. The design does have many drawbacks. The wedge is asymmetrical, as you have noticed, and in certain situations the propagating flame could compress some unburned air and fuel mixture on the most edge from the wedge, causing knock. Because of this and many other reasons, the hemispherical combustion chamber was developed. Also known as Hemi, this chamber is dome-shaped and it has a lot of things going for it. The Hemi is known for its excellent airflow, as there are no squish areas to block or disturb the airflow. We can fit by far the biggest 2 valves in this head. In theory, this chamber is close to perfect, but it's not close to reality. Since it's a hemisphere, it has by far the largest amount of surface area and volume. This leads to a very slow burning flame, combined with no squish areas to create turbulence or swirls. The mixture is not as homogeneous. This leads to compression of the unburnt mixture, which can create knock. This is such a prominent problem that early engines using a Hemi combustion chamber needed 2 spark plugs. Also, the valves are now positioned in parallel. This leads to having to use 2 camshafts or complex rocker arm pushrod arrangement, increasing the cost and complexity. This is also known as crossflow. In return, we can separate the intake port from the exhaust. Engineers decided to improve upon the Hemi, creating a masterpiece. The moment we have all been waiting for, the pent roof combustion chamber. The pent roof takes in all the knowledge from the previous designs and combines them into one. The pent roof gets its name from having 5 roofs. If we polish the joints, it takes on a look of a hemisphere. If we take a cross section, it looks like 2 wedges. This allows us to exactly fine-tune the valve included angle, which also allows us to fine-tune the compression ratio. As you have seen, the pent roof can hold as many valves as it wants. Often seen, it holds 4 to 5 valves, but Yamaha has managed to fit up to 7 valves in this configuration. The airflow, of course, is the greatest of them all. As you have seen, the compression ratio it's able to achieve is up to 14.5 to 1, only limited by knock. The ports going to the valves are usually straight, and with 4 valves for an average engine, you will understand why it's the choice of many Formula 1 cars. The hemispherical-ish shape also means it's a cross-flow engine, increasing cost, so the pent roof has the best knock resistance, and modern technology has led us to a pent roof combustion chamber with a pre-chamber design. A technology seen in F1 slowly making its way into the automotive industry. What it does, it moves the spark plug and the injector into a small chamber just above the combustion chamber itself. This creates the best knock resistance and efficient design yet. Note that some normal pent roofs also have squish areas around the valves. The pent roof is also used in all modern efficiency-compliant vehicles using petrol engines. Diesels use something else, the Heron combustion chamber. This is the simplest of them all. It's nothing but flat. It can have crossflow and 4 valves, sometimes offset off center line like in some Audis. The offset's purpose being to use one port as a faster flowing, since diesels operate at really low RPM, having a faster airflow beats more air volume. The most important thing about the Heron is that the combustion chamber isn't even in the head, it has been moved to the piston. The reason being is that in a petrol, we have the whole port and intake stroke to swirl the air and fuel to create our mixture. In a diesel, we have little to no time to create it. With the injector being at the top, we use the piston with a ball shape to create the mix. This leads to the piston with a really high chance of overheating. So the crown has to be really thick, adding a shit ton of weight to it. They also need more cooling, leading to some manufacturers to use an internal oil channel in the piston, supplied with oil from the oil squirters at the bottom of the engine. This is one of the reasons diesels don't rev really high. Trucks, on the other hand, ditch the aluminum piston and rather use a 2-piece design piston, where the crown is a really tough and high melting material like iron and the skirt is aluminum. To recap, the flathead saved money but sucked. The tub improved but it was still lacking. The wedge had better combustion, but valve sizes were limited. The Hemi improved airflow but could knock easily. The pent roof improved everything. The next part of this series will focus on the shape and size of the ports and why they matter in an engine head. Until then, peace.